Hello. You're hearing me? All good? Hearing and seeing? Yes, perfect. Thank you, Mazin, for a great presentation of use of IFC and conversion rules. There's a lot of great possibilities inside this tool with the IFC structure. What Mazin here has shown us. It's not just geometry information. There's so much more inside these structure possibilities. And hopefully I could show you some of this today with the work we've been doing in Switzerland. My name is Joachim Salomonssen. I'm working as a product manager by BuildingPoint Switzerland for infrastructure constructions. And been working there since September 2023. Earlier, I was a road planner by a Norwegian planning company, and have done a lot of experience with the Quadri software. Today, I will give you a short introduction to what is actually BuildingPoint and what we're doing in Switzerland, especially with focus over localization of Quadri and lower point work. What is then special when working in Switzerland, both with our localization, but also what is special for our customers that work with the planning and construction. How could IFC be a part of the answer to these requirements? And try to show you some project examples, and in the end, give a summary with our experience and evaluation so far. If you have any questions, feel free to ask them. I will try to keep an eye on the chat together with my presentation. So if it fits, I will answer them directly, or hopefully I have some minutes in the end. But feel free to ask questions. What is then BuildingPoint? BuildingPoint Switzerland. BuildingPoint, this is a franchise name from Trimble. So we will find BuildingPoint in many countries over the world. We have BuildingPoint Scandinavia, and we have BuildingPoint Switzerland, and further on. This is independent companies doing their own businesses, but all is partners with Trimble, and the most of them are focused on the software and hardware for building constructions. So this means then total stations and robotics, laser scanners from Trimble for surveying. We have Tekla for parametric modeling, and Trimble Connect for collaboration. BuildingPoint Switzerland, we also offer Quadri. So we are not only for buildings, we offer Quadri for the infrastructure constructions, and we have SketchUp for intuitive modeling and sketching, and also Site Vision, Trimble Connect AR for viewing, and also some other software in our portfolio from Grasshopper, TimpleBeam, to mention some of them. And we also have sister companies that are doing the GNSS services, Geosystems. So we are actually a complete partner for all type of construction contractors, planning companies in Switzerland, and they're talking of hardware and software. And my working area, as is then focused in the upper left corner here at the parametric modeling applications with a special focus of Quadri. The last year, I've been working with the localization and implementation of Quadri in the German-speaking part of Switzerland as the first German-speaking area. So this is also a real pioneering work. I think it's more than 15 years since Quadri last localized the product to a totally new market. And here we have a lot of challenging and interesting tasks, both with the translation, adaptation to laws, rules, and regulations, and working with templates and configurations to make it as easy as possible for all new users to use the software. I'm also a part of marketing and training, but luckily I have a colleague that is the main responsible for the marketing and sales. But what is then special with working with Swiss requirement and in Switzerland? Then I would like to ask you what you think about what is special or what you think of with a Swiss product. What is the first that comes into your mind when you think of Switzerland or Swiss made? From my point of view, I think of exclusive and quality. Example of exclusive watches. There's a lot of watch producers in Switzerland with a very high cost and high quality. And you also have the same with very fine chocolate products, cheese products. You all see the same. The quality ambitions is very high. And exactly the same we see when it comes to the construction industry. My best example is the curbs. In Switzerland, each canton, as each region, they have their own type of curbs. And each is, of course, different for each type of street. And it doesn't stop there. They also have their own transition, as we see here in this movie. That means that if you want to build a product library for all type of curbs in Switzerland, we come to around 600 type of curbs. And this they want to model and describe exact as built in their BIM models. So there's extreme focus on the details. This we also see for drawings. The technical drawings, I would say they look more like art than drawings to me. High focus on the colors, transparency, information level, all should be in the correct scale. They put a lot of effort in their drawings. That is also something we see in the planning software they use today. It is extreme focused on drawings and not on models. But they are also working with information, and many of the public clients, public owners, they have the different databases with different requirements to information, which they already use for services, maintenance, and their own information management. This is an example from Canton Aargau, where I'm working. Their database for the road administration in Canton Aargau, they have 444 pieces that can be used and connected to different objects in their BIM models. So the demand on information is high. And to these requirements and demand, the IFC, I would say, is a perfect answer. It gives the necessary structure and possibilities to detail their model and adapt it to their existing requirements. And with this, the help of IFC, the help of modern software, they want to take a big leap in the use of BIM. But are they already using BIM with what I already told you about the details, information demand, and focus on IFC? Yes, they are using BIM. But if we look at an old figure here, this figure has been used in a lot of presentations over the last 10 years. I stole mine from a user meeting 2019. So I'm not go that detailed into this, but we see here the different level of BIM. And in this figure, it looks very even and equal steps between the different levels. But I would say it's a very huge step from level 2 to level 3. A very clear change between those two stages. Because the main difference is when we're working in level 2, we work file-based. Often have each discipline have their own models where they do the design, then they exchange a file, and the files are put together to a collaboration model. But then your information is actually always outdated. It's never newer as the last export. And all this export, import, collaboration takes a lot of time. When you're working in BIM level 3, we all work together in the same model. Our working or design model is the same as our collaboration model. And this is exactly what we are doing with Quadri. And Quadri has been facilitating this over the last 10 years. That's why we in Scandinavia maybe thinking, isn't everyone using this? But no, that is not the answer. So if we look at the timeline, I don't see that we all are working at BIM level 3 in Scandinavia. But I'm saying that the technology, the knowledge, the software, the structure, it's all there, it's well known, and it's been used for the last 10 years. But in Switzerland, it looks a little bit more like this. Almost everything they do, they are very advanced models, but almost everything is at BIM level 2 with a file-based exchange of information. So here there is a very, very high potential for a more efficient work when you're looking towards BIM level 3 with one collaboration, one working model, common BIM, and further development with other services, integrating them into level 4 integrated BIM. And to succeed with this, the IFC standard, I think it's absolutely essential. And what is then so special with this? The standard that both I and Marcin have talked about today and many others, you hear especially IFC 4.3 a lot these days. For the first of all, this is the basis, the fundament for an open collaboration. This is what makes it possible to exchange information in an open format that all type of systems can use. Which gives us a necessary compatibility and interoperability between both different softwares, but also, if we look at the project lifecycle, this is also important for the exchange of information between different stages. Essential is the transfer between building and maintenance, where then a standard as IFC gives us the necessary tools to describe, deliver, and further extend this with more information. So you could take a you could compare this when you're trying to talk with someone from another country. If you have a common language, it's easy. If you don't have a common language, then you have to use your fingers, drawings, or something other smart. Then your communication is very limited. It's exactly the same here. When we talk the same language, we open up so many doors for more advanced communication and collaboration. But IFC is not a new standard. It's been available for almost 30 years, but it's been mainly a standard for building construction, not for infrastructure. This was made available this year with the IFC 4.3, which gives us detailed description of also the infrastructure elements. But it's not only geometry and information, like Marcin showed us, it's also fantastic possibilities for structuring of data in this standard. One example is the spatial breakdown, also the geographic localization of different elements. You see here an example with site, also on a work site, and then you have different roads, you have tunnel, you have a bridge. And when you select one of these spatial elements, all following elements that is connected to a selected road or select tunnel is also then selected. So this makes it much easier to manage the information, use it for further design, export, calculation, and so on. And also the information management is much easier. You then can add common information at a high level in the structure, and it is then further then taken down to all other elements. But it's not only the spatial structure. We also have different type of groupings and classification. I repeat just what Marcin has shown us very fast in his great demo. This gives us many possibilities for different type of structures that can be used together across each other. It's not so that one excludes another. You can make many different type of relation, groupings, and classification according to how you want to use the data. And this could be further developed with time, cost, and resource planning. The entities, they are already available, but they're very limited software support for using IFC for these type of planning processes. But this will come and will make even more different services and disciplines integrated into the model, and we're working towards BIM level 4. And as I said, many public clients in Switzerland, they're thinking that IFC is the correct answer to the further development of BIM and their information models. We have both the Swiss Federal Railways, SBB. We have the Federal Road Office, ASTRA, responsible for all the highway freeways. And also many cantonal road authorities are all building their information models on the IFC 4.3. And then I finally come to some examples from different projects. The first one here is a pilot project for model-based tendering. There was a street here of 500 meter length with some constructions and also a lot of pipes under the ground. They were going to do a total renewal. The complete tender process was done only based on one IFC 4.05. IFC 4.3 was not available 1 year ago. That's why 4.0. But they made this complete model in one file, made it available with Trimble Connect, where the different contractors could view the model, view the structure, get a great overview, and export the necessary information for their further calculation. And here is a table function. It's a really, really great tool that gives us the possibility for different groupings, summation, and export to Excel. They also had the possibility to ask questions with the to-do function in Trimble Connect. And then the question is connected directly to an element, so it makes it very easy to understand what is here, the topic. I have to also to comment, the final offer was delivered as a traditional document, paper-based. And the reason for that is that, from my knowledge, there is yet no free tool that makes it possible to add information to an IFC property or IFC file. But when that comes, as an example, as an extension to Trimble Connect, then it will be possible for the different contractors here to add a unit price as a property, and then automatic calculation of the cost when you multiply the unit price with the quantities. And then we actually could deliver also the offer as a model and have all information as properties in the model. So this will come. Here you see a print screen from the model in Trimble Connect. In the table displayed below here, you see the different contract codes with description and the quantities. And I have here grouped them by object type and name. This you can structuralize just as you want, what is necessary for your calculation, export, work further on in Excel. And you also see the spatial structure in the left side of the screen. From one small to one very huge project, Cargo Suez Terrain. This is one of the biggest infrastructure projects in Europe, but you maybe not heard of it. And the reason is that it is still in a very early planning stage. They have been working with it for over 30 years, but it's going back and forth in the moment, a little bit back. But this is a very interesting project. Said in one sentence, an innovative response to the challenges of logistics in a modern society. In Switzerland, we have exactly the same issue with logistic and cargo transport as in all other Western countries. The demand for logistic is rising for each year, but there are not more space in the highways and train railways. So what do we do then? Do we either just build more of what we have, but then get even bigger problem in all intersections or transfer points? Or do we think all new? That's what they have done here. Switzerland have a long history with building tunnels, and here they want to take the principle from the subway and build a tunnel through the whole Switzerland, from Geneva in southwest to St. Gallen northeast, in total a distance of 500 kilometers, with some also adaptation to other cities connections. They are looking at a tunnel system where you then have hubs or stations, either at traditional logistic points outside the city, or also in the middle of a city. The last is great to reduce the demand for local distribution. So here you can then, in the hub, you can collect a different type of cargo. You put it in small wagons. They go in an elevator down to the station, where you then put it together with other wagons. This is all self-driving wagons. They go either to the next station or pass by if it's a longer transport. It goes up to the next hub and further distributed. So yes, as I see in the chat, an amazing concept, and I really hope that this will succeed. They have a lot of issues, still in the early planning, but the concept is very great. One thing is the physical infrastructure, but the Cargo Suez Terrain want to build a complete ecosystem where they take care of the local distribution, only environmental friendly vehicles or bicycles, short distance, easy transport, and everything is going to be digitally controlled. They have control over all different parts and want to connect it with the use of cloud services, AI, and further on. And they are then inspired by the fourth industrial revolution. They call it this for logistic 4.0. Everything automated, optimized to both use the physical infrastructure, but also the different elements here as good as possible to then in the end reduce the environmental impact of this. And yes, it's a perfect use case for the IFC. That's also here the demand to do the whole project, both design and operational in IFC 4.3. And you see here the design requirements for their platform. A typical BIM level 3 to BIM level 4 project, when they then take in the progress planning, quality and cost calculation. That's not, as I said, possible today, but it is possible to connect all the software together. So we then have one model with all the information. That is possible, but it's not possible to do it all in one solution today. And what is also great is that they have decided to use Quadri as their core system here to build up this model with all connected features and services. So I'm really looking forward to follow this project further on. Last project, this is something you see a lot of in Switzerland. almost all what they have of documentation for existing infrastructure elements as road, water and sewer, electric distribution nets, everything is paper-based. And they have a lot of projects where they want to create exact models of the existing situation. This is a project from the Federal Road Authorities, Astra, done by a planning company, HAMCO, with Quadri software. They had a 4-kilometer highway in a typical Swiss terrain, very steep. So then there is a lot of constructions. And then want to build or establish a model of this in IFC 4.3. And here you see the result in Quadri. They have used InnovaPoint tools for road, water and sewer, Tekla tools for all construction, Grasshopper for guardrails, and other elements that was not was very repetitive. They have done light poles as an example. It's then done in Grasshopper. And all is connected through Quadri to the use of connectors. This is not from the project, it's from a demo I have, a demo video, but just take the first here to show you how we could work them. Construct a bridge in Tekla. I send the bridge back immediately. It's available in Quadri. I do the same further on with Revit. I get some lines from a road model, send this to Revit, use this as a reference, design here a wall. All is then the designer has the possibility to choose what is my design reference. All is object-based, no files. This is a fantastic way to work together, also with other types of software that is not in the native Trimble family. But here you see then the bridge, what is designed, or one of the bridges designed in Tekla. They also used here, I must say, the connector between Tekla and Grasshopper component. This is working a little bit better than the direct connection Quadri Grasshopper. They also use the bridge generator a lot, but all other is typical Tekla elements. When we see this finally in IFC, this is generated then with the new IFC feature catalog in Quadri, with the desired special breakdown structure, properties, exported as one file. Then some experience and evaluation. What have you seen so far after 1 year of use of IFC 4.3? Correct use requires experience. And I repeat myself, but Marcin's presentation was a very good example of this. Yes, it is a lot of different, not different standards, but a lot of information. A lot of different relations, different elements. You don't know to have a complete overview of everything. You don't need to understand everything, but it's important to know that it's a complex structure and know what is the different type of element used for. That is very useful. So yes, it requires experience, but it makes our data transfer very much easier when we have a common language. We also see that there are limited support in many software, but that will be fixed, it will come. But it can be elements that are not shown up, geometry is not shown correctly, some entities are not supported and so later. And there's also not possible to do a design or recalculate directly in IFC today. I cannot import an IFC road, recalculate it and export it from Quadri. That's not possible today. But when this comes, then it will solve many issues, especially when exchanging information between different stages. When we put every information together, I would say this should not be an issue today, but we put all information in one file. It leads to large files. We're talking of 2, 3, 4, 5 gigabytes, and many IFC viewers have problems with this. But with the support of cloud services and other solutions, this should not absolutely be possible to solve. And it is necessary to put everything together to keep the relations. But I see a very potential efficiency improvements, both in the design phase, operation phase, maintenance phase. both in focus of information, how we could take care and maintenance information here, easier to select the correct object in the information, easier to structurize it, all come to the information management, but open up a lot of doors, possibilities, and improvements. Good. That was my presentation. Thank you a lot. Hope it was interesting. You now have a break. So if you have any questions, I could probably ask for them directly. Revit Civil 3D and Quadri is one question here. Maybe should someone from Trimble answer what is the further plans, but in the moment, there's a new release of the Civil 3D connector. So all Civil 3D elements are supported by the connector. So then we could import Civil 3D elements to Quadri and export them further on to Revit. That should work. But when exporting to Revit, be aware of that it is actually an IFC elements what the conversion is done by. So there are some limitations in the Revit by importing IFC elements. Yes, you could also feel free to send me questions. Was one more? Yes, customized presets work. That is no problem. You have to do your own conversion rule, both from Civil 3D to Quadri, for Quadri to Revit. But in this operation with the conversion rule, you could take care of your own preset also. Yes, feel free to send me email if you see anything more.